In this topic, we're going to look at how to use type extensions in your F# code. And a type extension does pretty much what it sounds like it does. It allows you to extend an object type by adding new members to it. There's two forms of type extensions. We can have intrinsic extensions and we can have optional extensions. An intrinsic extension is when your extension shows up in the same namespace or module that's in the same file and in the same assembly as the original type. So let's add a module with a student class and then look at how we can create an intrinsic extension for it. So we'll have our module school module, and then we'll create a student class for it, and it has a few properties. Now, normally we'd have a number of other classes here, some other functions, other things that would go into our school module. But we can now create an extension for our student type, which would ideally be located further down, by using the type keyword, then our student class name, and then using the with keyword. So we have type student with, and that's indicating that we're going to create an extension for our class. And then we can go ahead and add in additional members for our class. So we can have member this dot sortable name equals, we'll have this dot first name plus a comma, and actually we'll do for last name for the sortable name. So this dot last name, then a comma, and then the actual first name. Now when we go to use an instance of our class, we'll actually find our sortable name method listed in IntelliSense as part of the class, as long as our module is open and it's still in scope. So let's go ahead and add another module. And in this one, we'll have a custom module that has a student detail method, and it accepts a student class and then prints out our sortable name is and calls our student.sortableName method. So when we're using that student value, so we can do our student.sortable name, and that it does appear in IntelliSense. So it behaves just like a regular part of our class, or of the original class. And then we can have some code that actually creates an instance of our student class. So new school module dot student, and we'll call her Sue Waters. And then we can call our custom module dot student detail, pass in our student instance. If we run it, we'll scroll up and we see that our sortable name has been printed out. So as I said, our extension, it just adds a new member onto our original student class, but it doesn't have to be in the original type that you've already written out. So using intrinsic extensions can be a good idea when you want to separate parts of your class file. Perhaps you have some code that was auto-generated by a Visual Studio tool, and you like to keep that together, while any developer-generated code would be found elsewhere in the module. And it might be so that it doesn't interfere or get lost with that auto-generated code. The other type extension is an optional extension. And these occur when you're trying to extend a class, but it's being done outside of a namespace or assembly of the original type. So let's take a look at adding an optional extension to the system.string class. So we can have type system.string, then with, and let's add a new member, this.add decorator. And we'll pass in, or we'll be expecting a character to be passed in as a parameter. And we'll just say let padding equal pad left 5, C. So it's going to create a string that's 5 characters in length, and it's going to use our argument C that's been passed into the add decorator method to actually fill those blank spaces. And then we're going to return padding plus this plus padding. So we'll decorate our string on both sides with whatever character was passed into the add decorator method. Now we're extending our system.string class by adding this add decorator method. And since we're not working directly inside the system namespace and we're not within the DLL file, this is going to be an optional extension. So if we go ahead and create an instance of a string class now, we'll say let mutable, well, we can just say let city equal Montreal. We go to print that out now, and we'll pass in, we can call city.addDecorator. So it's showing up in our IntelliSense. It just looks just like it's part of this string class. So we'll add a decorator and we'll pass in asterisk as our character. So now if we run this, we'll see that we have Montreal is being printed out with our asterisks located on both sides of our string, but we have 5 of them on each side. So that's decorating our string with those characters. Now, no matter what type extension you're using, your extension methods and properties can't be declared as virtual or abstract, but you can go ahead and overload all these methods. So in our topic, we talked about the 2 forms of type extensions. There's intrinsic extensions that are created with the same namespace and assembly as the original type. And we have optional extensions, which see you adding members to types that are located in other assemblies. Now, both methods use the syntax of the type keyword, then the type name, and then the with keyword. And that's to indicate that you're going to be creating new members for that type.